When a car stalls while driving, the issue frequently originates within the fuel delivery system, which is responsible for supplying the engine with pressurized fuel at the correct air-fuel ratio. Common failure modes include a clogged fuel filter, a failing fuel pump or relay, a leaking fuel pressure regulator, or contaminated fuel, such as water infiltration. These issues often manifest as stalling under load or at higher speeds, typically without a rough idle beforehand. The engine will usually crank and restart after the stall. To diagnose these, one should attach a fuel pressure gauge to measure static and dynamic pressures, monitor pump current draw, test the relay circuit, and inspect the fuel for debris or water. The ignition system, which generates and times the spark for combustion, is another frequent culprit. Problems such as faulty ignition coils, worn spark plugs, degraded distributor components in older cars, or failing crankshaft or camshaft position sensors can cause sudden shutdowns without warning. Drivers may experience erratic acceleration or rough running and find that the vehicle may crank immediately after stalls. Technically, one should inspect spark plug condition, test coil resistance, and use an oscilloscope to verify timing signals, particularly the crank sensor waveform. Scanning for codes like P0335 is crucial. Issues in the air intake and vacuum systems, which control airflow and stabilize combustion, can also lead to stalling. Failure modes include contaminated or failed MAF or MAP sensors, vacuum leaks, and malfunctioning idle air control valves or throttle bodies. Symptoms often include a rough or choppy idle, hesitation or surging, and stalling at low RPM or idle. Diagnostic methods include cleaning or replacing MAF sensors, monitoring live PID data for voltage fluctuations, smoke testing the intake for leaks, and checking throttle and IAC operation. Several engine and emission sensors provide critical input to the ECM. When they fail, the engine may stall. Faulty crank or cam position sensors disrupt timing sync, while a failing throttle position sensor, coolant temperature sensor, or oxygen sensors can lead to improper fuel adjustments. Symptoms may include unexpected shutdowns, illuminated check engine light, and erratic idle behavior. Technicians diagnose these by reading live data from a scan tool, observing sensor outputs during operation, and interpreting stored and pending codes. The electrical or charging system, which supplies stable voltage to all critical components, must also be considered. A weak alternator or battery, bad grounds, corroded connectors, blown fuses, or wiring shorts can cause intermittent voltage loss, leading to stalling. Indicators include dashboard flicker, electronics resetting, no start conditions after a stall, and codes such as P1684. Diagnosis involves measuring system voltage under load, ideally over 13 volts. Performing wiggle tests on harnesses, inspecting grounds, and scanning for power loss events. Mechanical or drivetrain-related issues may also stall the engine under load. A seized accessory like an AC compressor or alternator, transmission load issues, torque converter failure, or a failing belt can suddenly drag the engine. Stalls often coincide with accessory load, produce abnormal noises or vibrations, and may involve belt smoke or braking. To test, one can disable the AC under load, visually inspect belts and pulleys, and examine transmission fluid and torque converter operation. When summarizing urgency, ignition, and fuel system failures present the most immediate safety threats. Electrical issues are also high priority, while sensor, air intake, and mechanical accessory faults may be medium urgency. Testing involves a combination of fuel pressure measurement, oscilloscope tracing, sensor live data monitoring, voltage checks, smoke, vacuum testing, and visual or mechanical inspections. A robust diagnostic workflow begins with scanning for trouble codes and logging live data, followed by verifying battery and alternator health under load. Next steps include performing fuel pressure tests, inspecting the ignition system with component and waveform tests, assessing air and vacuum system integrity, validating sensor outputs, TPS, O2, coolant, examining wiring and grounds, and evaluating accessory load. A final road test with live data logging helps capture stall events while driving. To narrow down the issue, answer questions such as, does the stall occur at a specific RPM or load condition? Do dash lights flicker? What codes are present and what live data values stand out? What were the static and loaded fuel pressure readings? Has wiring been tested for continuity under load? Preventive measures include replacing the fuel filter according to OEM schedules, inspecting and servicing spark plugs and coils regularly, cleaning MAF and throttle components, checking vacuum hoses, maintaining the battery, alternator, and ground connections, and replacing crank touch cam sensors at the first sign of glitches. Belts and timing components should be replaced on schedule. In closing, prioritize safety. If the stalling issue causes loss of control or occurs at highway speed, avoid driving and tow the vehicle for diagnostics. Use data logs and oscilloscope traces to capture intermittent faults, and start with simple checks such as scanning and voltage testing before replacing parts.